Okay, so you've already been doing AP style problems all year in your after parties. We've been doing them in notes. I'm going to kind of like highlight that we're doing them more this semester as we get closer to the AP test. AP test is not the most important thing in the world, but man, you guys are in here all year, you're learning all this calculus. I want you to get that college credit for it, okay? I don't want you to know a lot of calculus, but miss points on the test and therefore not pass. Okay, so this actually is not an AP style problem. This is an actual old AP test question that's been released. Okay, and like word for word. And these problems are always worth 9 points. On an AP test, there's 6 of these. And so that's 54 points. You have 45 multiple choice. They scale that to 54 for a total of 108 points. Okay, and remember, you're not looking for a 90% to get a 5. Typically on these, if you can score between 4 and 5 points, that's good. That's in the passing range. Obviously, you want to score as many points as you can, but don't like look at this as, man, I only got half of it right. That's failing. It's not. That's pretty good. So as we go through this, some of these points, you may be thinking, never would have thought of that. But then there's other points that you're going to be able to get, especially with practice. So in this problem, we have it's similar to the ones that we had done before, at least the context of the problem, very similar. The rate of fuel consumption in gallons per minute recorded during an airplane flight is given by a twice differentiable and strictly increasing function of r of time t, and we can see that here. The graph of r and a table of selected values over the time interval 0 to 90 minutes are shown. So they give you both. It is possible that you may only given the table, in which case you could make a graph if you wanted to. For your use. And so I'm going to kind of use both of these since we're given it. So the first question, the first thing they tell us to do is to use the data from the table to find an approximation for r prime of 45. So this is what we're going to write. We're going to write r prime of 45 approximately equals. Okay? The most important thing in a problem is that you understand what it is you're even looking for. Okay, so what do you guys think? How is r prime relating to r? So r prime is positive, so my answer should be positive here. Because it says r is increasing. But how does r prime, just in general, how does f prime relate to f? It's the derivative. What other word do we have that's like really closely linked to derivative? Slope. Is there another phrase, maybe 3 words long, that means slope? Rate of change. Okay? Now, the reason I bring up rate of change is because we have an average rate of change and an instantaneous rate of change. Okay? And they're not always the same. So what they're really asking us to do is to find the instantaneous rate of change, but I can't find it. I don't know what r prime of 45 is exactly. So thank goodness they're only asking us to approximate it, which means we do get to use average rate of change. And that's good because there's no equation to take derivative of here. If there was like r of t equals this equation, we would take derivative, we'd plug in 45, and that would be easy to do. All right? You kind of have to read between the lines here. We're going to approximate the derivative by doing average rate of change, which is just a basic slope problem. So look at the table. I don't see 45. If it was anywhere, it would be right here. And so what we're going to use is the information right around 45. The best answer here would be the numbers that are directly on either side of 45. This is like the first problem of your after party, by the way. Let's do this week. It's similar. It says differently, but in the end, this is what you do on the very first problem of your after party. So what goes on top? Right. R of 50 minus R of 40. And then 50 minus 40 goes on the denominator. Some of you might have been thinking, well, I was just going to write 55 minus 40 over 50 minus 40. In other words, y2 minus y1 over x2 minus x1. This is great to see, but I will tell you, you got a point here, either way. What you can't do is do all the work in your head and then write the answer. You lose points that way. Okay? So you had to show the work to get one of those 9 points. The other one came from the correct units. So by the way, this turns out to be 1.5. All right? And you have a calculator, that should be pretty easy to do. What are going to be the units? Gallons per minute squared. Now here's how you know this. All right, 55 and 40, those were gallons per minute over just minutes. So you may be thinking, well, did the minutes cancel or did the minutes make a square? So what would have been totally fine here is if you didn't know, gallons per minute over minutes. Like this was okay too. All right, you could have written the units either way. But what you can't do is make a mistake in thinking this is only gallons. That's not, that you're going to lose the point. So 1 point for your work, 1 point for the answer with the correct units. Meaning, if you don't have the correct units, you miss a whole point. That's more than 10% of these problems. So that's why I'm making a big deal out of it. Okay, so then we look at B. The rate of fuel consumption is increasing fastest at time t equals 45. What is the value of r double prime of 45? So I'm going to go ahead and write r double prime of 45 equals, it doesn't say approximate, it says, what is it? So surely we're able to calculate this exactly. This is not a guess, an estimation, we're going to know what this is exactly. So you may know the answer, but I know not everybody in here knows what it is right away. It's not totally obvious. Let's look back at the graph here. So here's 45 right there. Okay? What this sentence is saying is that the rate of fuel consumption, in other words, R of t, is increasing fastest. Okay? So that means that that's the steepest part of the graph. Okay? The slope is the biggest right here. And they're saying, well, what's the second derivative then? Any ideas? 0 is the answer. How did you know that? How did you know this was a point of inflection?
It's the steepest where the graph is and changes.
So you kind of remembered when we went back and forth between f prime, and f double prime, and you're using concavity, which I really like. This right here, the second derivative, is positive, right? Concave up. And we can even see that. And then it gets really, really, really steep. And then this part of the graph, at least for a little bit, the second derivative is negative. It goes concave down. So where the graph changes concavity is a steep point on the graph. That's a point of inflection, so the second derivative should be 0. A totally different way of looking at this, it's not totally different, but it's coming at it from a different angle, is thinking, okay, well, what's the deal with r prime? I'm going to switch colors here just to point this out. So if this is super, super steep, r prime has a max right there. What do we know about the derivative at a max? Right? It's 0. So r prime has a max. R prime's derivative is r double prime, and that would be 0. So it's using all that stuff that we did before. It's just kind of in a different way. We do need to go ahead and put units here. They don't ask for it, and they actually did not count off because it's kind of a weird thing. Like, what is gallons per cubic minute? That's weird. All right, what does that mean? So they didn't require it. I'm going to tell you, if you have units, you always need to be putting units on. And if you're like, how did I get cubic? Well, R was gallons per minute. R prime was gallons per minute squared, because essentially you're just dividing by time. You're doing like a rate of change. And so this would be gallons per minute cubed. All right, we do need to give a reason. Now, we could go into the whole concavity thing, but I'm really just going to kind of take what they said and put math names to it. So rate of fuel consumption, that's R of t. increasing fastest means, oh, that's R prime as a max. But you could definitely explain this using concavity. You're just going to have to put more words to it if you do that. And we should always say, sorry, I'm getting tired at the end of the day, we should always say the time. Because this is only happening at 45 minutes. Okay, so then the next part, so you might have been like, ugh, I never would have gotten that point. Well, the next points are a lot easier to get. It's like what we've been doing with Riemann sums. Approximate the value of, so I'm going to stop right there. I'm going to rewrite this. It doesn't matter if we're comfortable with it or not. You can rewrite it. And approximate means, what is it about? So up here, approximate meant average rate of change. Here, it's saying use a Riemann sum, a left Riemann sum. And they even tell you 5 subintervals. So this is something that you should be able to do. This is totally quiz material right here. So go ahead and try to do this part on your own. And okay, what are we getting? Some of you are taking them all calculations since you don't have your calculator, but most of you had something written down. What'd you get? If you were like, I didn't quite get that number, look at the calculations here. It's possible you had 20 times 30 instead of 30 times 20. You know, that stuff doesn't matter.
I'm taking dictionaries for ELA test.
Sure. Go ahead.
Or are they right now? You can say.
Okay, so then what we got to do, because that's one more point, and this is a point you can get. You think 1 point, but 1 point's a lot. You're welcome. So then, is this numerical approximation less than the value? Well, if you're not quite sure, I'm going to erase all this business right here. We don't really need it anymore. You could just take one of these and look at it like that. And that's what you're finding each time, were these rectangles. So is the Riemann sum less than the true value? That's right. Yes.
So is that true for the whole graph?
The graph is strictly increasing, so yes. Every rectangle is going to be less than the true value. Now, if the graph went up and down and up and down, I could not answer this, and they're not going to ask you to do that. It's only going to be on these graphs that are only increasing or decreasing. So we need to say, like, why. And it's because R of t is increasing. Okay? That's another point. So even if you totally messed up on part B, I really think you guys can get 4 points. Remember, 4 to 5 is what we're shooting for. Some of you need to be shooting for a lot more than that. It kind of just depends on whether you're really wanting a 5 or you're just wanting to pass. It's kind of like a personal goal. Okay, so now we got to do some writing. Everybody's favorite. Some people really do like this, and they get a lot of points on this stuff. There's usually a writing element. We've written a little bit, but this one's more writing than the other parts. So it's saying for 0 to 90 minutes, explain the meaning of that in terms of fuel consumption for the plane. So we're just going to start out. We're never going to leave anything blank, because you never know what you're going to get a point for. Don't leave stuff blank. So what does this mean? Well, I just found it. It means number of gallons. And so that, it says indicate units of measure. And so I already did that. Now I need to give this a context of the plane. Number of gallons of what? Of fuel consumed by the plane. You don't have to use this language, but something like this. You got to bring it back to the context of the problem. So it's the number of gallons of fuel consumed by the plane. So units, context, then interval, time interval. You have to include that. So we have to say on the interval. Now, there are other ways to do this, but what you're never going to go wrong with is just going back up here and saying, there's the interval right there. I'll just repeat that word for word. That's always going to work, and that's what I'm going to suggest that you do. Okay? And make sure you have units on that interval. So this is a point, especially when we practice it, this is a point I know a lot of people can get. Some people who even mess up with the math, they can get this. Now that's the first part. Look at what they're asking us to do next. So this is a very similar thing. Now think about this. When did we do a Riemann sum and then divide by b, which would be the total time interval?
When we were trying to find the average.
And we're trying to find the average. So 0 to b, let's 1 over b in front of it. And I had you guys write this on your papers, remember? And it was just to kind of get you used to seeing it. They're not going to have it all over b. They like to put this as like 1 over b in front. That is the average. Well, the average of what? The average of whatever r of t is. Right there, this thing. What was in the table. So the average of r of t, it says, is fuel, the rate of fuel consumption. I need to tone that down. Here we go. Average rate of fuel consumption. Why am I having such a hard time? Okay. Consumption. On the interval, and you could say of the plane there, they wouldn't take off here because we've already been talking about the plane in this problem. Average rate of food consumption on the interval 0 x b. And so all day today, people have been like, well, couldn't you just say this or this? It's not like one sentence they're looking for. But they are looking for these 3 parts. I did leave out one of my parts. And I didn't do that on purpose. That's just a tired me at the end of the day. What did I leave off in the second one? Unintentionally. And it would have cost me this whole point if I had left this off on the test.
You left out gallons.
I left out what this is going to represent. So like here, I had my units. This is... right here, I should have said in. Now, it's not actually gallons, because remember, we're dividing by the total time. So we're back to gallons per hour. But, per minute, sorry. But here's another way I'm going to tell you guys. Look up at R of T. Remember, that's what we're averaging. What were the units on R of T? Gallons per minute. So this was the last 2 points here. I think there were 3 points up here. One for the work, one for the answer with the units, and one for the reason. I can't remember exactly. Okay? So